Okay, let us start the class. Yesterday we had discussed the nodal analysis. In nodal analysis, what you have determined? In nodal analysis, what you have determined?
KCL.
Node voltage and
branch currents.
branch currents. Okay. So in the previous classes we have discussed only the voltage source. So this is the voltage source. This is the positive terminal, this is the negative terminal. The bigger terminal is the positive terminal and the smaller terminal is the negative terminal. This is the voltage source. If you come to the current source, this is the symbol for the current source. Remember that current always flows from negative to positive. Current always flows from negative to positive in the upward direction. That's why I have represented the arrow in the upward direction. I have represented the arrow in the upward direction. Current symbol is this. Suppose if this terminals are interchanged, the arrow will also be in the downward direction. Remember that in voltage source, current always flows from negative terminal to positive terminal. Current always flows from negative to positive in voltage source. Okay. So the arrow, see the current, this is the symbol for the current source. The arrow is represented in the upward direction. Why I have represented in the upward direction means current is from negative to positive in the upward direction. Suppose if the voltage source is like this is the voltage source, then current will be in the downward direction. Because from negative to positive current will flow. The arrow will be in the downward direction. This is the symbol for the current source. Note down this. Note down the voltage and current sources. These are the independent voltage and current sources. Independent voltage and current sources. And write down the note point. Current flows from negative to positive terminal in voltage source. Write down note. Current flows from negative to positive terminal in voltage source. Current flows from negative to positive terminal in voltage source. Draw those figures. Independent voltage source, independent current source. Independent voltage source, independent current source. Depending on it. Current flows from negative to positive.
Sir.
But here current flows from negative.
Sir, can you repeat the note, sir?
Note. Current flows to positive. Current flows from current. Since current is flowing from negative to positive in the upward direction, arrow is in the upward direction. Let us note. Current flows from negative to positive terminal in voltage source.
Sir, your video is stucking.
Yes, sir. Your voice is breaking and lagging, sir.
Video is not clear.
Video is clear, sir. Only your voice is lagging.
Voice is lagging, sir.
Okay. Write a note. Current flows from negative to positive terminal in voltage source. Now is it clear?
Hi friends, Navala pitch friends.
Sir, what
Hello.
division, sir? This champ.
My voice is clear?
Yes, sir.
Okay. Any doubt in this voltage source and current source? Why the arrow is represented like that in current source? Okay.
Sir, the down one is dependent source, sir. The second one.
Both are independent sources only.
Okay, sir. Okay.
Just the direction is changed.
Okay, sir.
We are not discussing about dependent sources now. Later we'll go for dependent sources.
Okay.
Heading source transformation. Source transformation. Source transformation. Source transformation means converting voltage to current source and converting current source to voltage source. How to convert the voltage to current source and how to convert the current source to voltage source. We will see now.
అన్న రెండు దమ్టి.
What happened?
Nothing, sir. Continue.
Not visible?
Visible, sir. Continue.
Hello?
Continue, sir.
Okay.
Sir, can you remove that one
Yes,
name
sir.
is added like my name only, sir, Sujit Sam 007. Can you remove that person?
Yes, sir. They are disturbing class.
Yeah,
From our class, sir.
Who is that roll number?
Sudhit Cham, sir. Sudhit Cham.
What is the roll number?
007.
7, sir.
007.
Yes, sir.
సారీ సార్.
Why you are making disturbance? 007. If you want to move out of the class, you can move. No problem.
Remove, sir, not
from
our
our class,
class.
sir.
I came out.
Okay.
They are not our
We'll
class.
see.
Sir,
Not
sorry.
our class, sir.
He is
Remove
not.
him, sir.
Remove
Okay,
him.
007.
Okay, sir. Continue.
Listen here. Here we are having the voltage source. Write a note point. Always resistance should be in series with the voltage source. Write a note. Always resistance should be in series with the voltage source. Always resistance should be in series with the voltage source. Next one. Next diagram. Always resistance should be in parallel with current source. Second point. Always resistance should be in parallel with the current source. Always resistance should be in parallel with the current source. Now we'll see. how to convert this voltage to current source. Let us take this 10 volts R is equal to 5 ohms. Now in the first diagram, I am determining the current here. I is equal to V by R. I is equal to V by R. V is 10. The resistance is 5. That is 2 ampere. Your current is 2 ampere. Now I want to convert this 10 volts to current 2 ampere. So here in place of I will keep 2 ampere. I am keeping 2 ampere. Always when you are converting the voltage source to current source, see direction from negative to positive. That's why I have taken in the upward direction. Negative to positive terminal. That's why I have taken in the upward direction. 10 by 5, that is 2 ampere. I am keeping as it is 2 ampere. After this voltage is converted to current now. Now what about the resistance? Whatever the resistance that is connected in series, the same resistance should be in parallel with the. We should not change this resistance. The value should be same. We should not change this resistance value. The same resistance we have to keep in parallel with the current. In this way, we are converting the voltage source to current source. See the arrow in the upward direction. Y means from negative to positive, current will flow in the upward direction. This 10 volts I am converting into current source. I is equal to 2 ampere. 2 ampere, and the resistance which is in series with the voltage source, that resistance should be in parallel with the current source. The same resistance value will not change. So this is the conversion from voltage to current source. Now see, for converting the current source to voltage source, here V is equal to I into
R.
is I to your resistance is 5. 2 multiplied by 5, 10 volts. Now this current source is converted to voltage source. This 10 volts I am keeping as it is. Okay. In the by keeping negative at the bottom, positive at the upper terminal, because arrow is in the upward direction. This 10 volts I am keeping. Whatever the resistance in parallel, the same resistance we can connect in series. In this way, we can convert the voltage to current source and current source to voltage source. But resistance value will remain same. To voltage source, it will be in series, but for the current source, it will be in parallel. Note down this. We'll do some examples so that you can understand better. Note down this. Source transformation means we are converting voltage to current source and current source to voltage source. Okay. Write down the question. Convert the entire circuit. Convert the entire circuit into single voltage source and single resistance. Convert the entire circuit into single voltage source and single resistance. Convert the entire circuit into single voltage source and single resistance by using source transformation. By using source transformation. So in the problem, draw the circuit. Afterwards we'll discuss. They are asking to convert into single voltage source and single resistance. In the circuit, there should not be any current source. Only voltage source should be there.
Sir, without using I1 and I2, we are using this current source, no, sir?
Okay, we have to convert the entire circuit into single voltage source and single resistance. See here, now I don't want the current sources in the circuit. First I am converting this current source into voltage source. What is here arrow is in the upward direction. What is the voltage now? I want to convert this one into voltage source. What is the
12
voltage?
volts.
12
volts.
V equal to IR, sir.
Okay. This is 12 volts. What about this resistance? Where we have to connect that resistance?
Series.
In
Series, sir.
series with 12 volts. I am connecting in series with 12 volts. These 2 ohms, this 12 volts, see negative terminal is down, positive because arrow is in the upward direction. Current flows from negative to positive. Okay. This 12 volts is in series with 2 ohms now. Now this part I am removing. After removing this, we are getting this. Now connect this 4 ohms here. 4 ohms. This will be 12 volts. Now convert this into voltage source. What is the
27 volts.
27.
27
27.
27? Okay. See the terminal how I am drawing.
Negative to positive, no, sir.
Negative to positive, downward direction. Arrow is in
Yes.
the downward direction. Now what is the resistance? 3 ohms. That 3 ohms I am connecting in series. This is 27 volts. So draw that. In this way we are converting the current source to voltage sources. Now in the problem he is asking there should be only one voltage source and one resistance. See here. Now take any direction. Either this direction you can take or this direction you can take. You will get the same answer. Okay. Any direction you take. This is only reference direction. Okay, I am taking one reference direction to convert into single voltage and resistance. Now, let us take this arrow is moving from minus to plus. Minus to plus means plus 12. Arrow is moving Sorry. See here, arrow is moving from minus to plus, plus 12 volts, plus to minus, minus 12 volts, minus to plus, plus 27. Total voltage is your 27 volts. The arrow will be from minus to plus. That is if you are getting plus, take here minus and plus. Even if you write here also, the bottom lower terminal will be negative, upper terminal. If you are getting plus, take here negative and first. And whatever the resistances, all are in series. 2 plus 4 plus 3. If resistances are in series, we will add the resistances.
Yes, sir.
2 plus 4 plus 3, how much? 9.
9, sir.
9 ohms. So we have converted the entire circuit into, simplified the entire circuit into single voltage source and single resistance. In this way, why we are using source transformation means the purpose of source transformation is to simplify the network. For simplification of the network, source transformation is very, very important. That is the only reason why you are going for the source transformation. Note down this. If you are hanged out, you can ask me.
Sir, why calculating that 12 volt, why we took only one resistance?
In the problem, he is asking to simplify the network. We are simplifying the
No,
network.
in the
Oh,
first diagram,
oh. Tell me.
the first simplified diagram.
In the first simplified diagram, what do you want?
For calculating that volt, why we have take only one resistance, but there are two resistance, no, 2 ohm and 4 ohm.
3 resistances are there. See, this is 1, this is 2, this is 3. All are series. Suppose if you take R1, if 3 resistances are in series, what is the equivalent resistance? R1 plus R2 plus R3. So that is the single resistance, total equivalent resistance. If 3 resistances are in parallel. Suppose if resistances are in series, that is the equivalent resistance, R1 plus R2 plus R3. Now let us take 2 resistances are in parallel. Now what is the equivalent resistance for this?
1 by R1 plus 1 by R2.
Okay. See here. Now see here. If 2 resistances are in parallel, equivalent resistance is 1 by R equivalent is equal to 1 by R1 plus 1 by R2. If you take LCM for this, you will get R2 plus R1 by R1 R2. This therefore R equivalent is equal to R equivalent is equal to R1 R2 by R1 plus R2. This formula you have to remember if two resistances are in parallel. If resistances are in series, we will add all this. If resistances are in parallel, this is the formula R1 R2 by R1 plus. Note down that. So that is the reason why we are converting all the resistances in series to single equivalent resistance. We are converting into single equivalent resistance. And also voltage source also. We are converting all the three voltage sources into single equivalent voltage source. Okay. If they are in series, we will add. If they are in parallel, resistance we will take R1 R2 by R1 plus R2. Note down the diagrams. R1 R2 R3 and series and also parallel in note down. The formula is, if two resistances are in parallel, the formula is R1 R2 by R1 plus R2. Remember this formula. R1 R2 by R1 plus R2. Is the doubt clear? Okay. Now we'll go to the next topic. We'll do one problem on nodal analysis before going to the next topic. Write in the question. Determine node voltage and branch currents. Determine node voltage and branch currents using nodal analysis. Determine node voltage and branch currents using nodal analysis. Determine node voltage and branch currents using nodal analysis. How many nodes are there?
Two nodes. Sorry, four nodes. Four nodes.
There is only one node. See here. There is only one node. Because all the branches are connected to single point. Okay. See here. All the branches are connected to single point. Let us take this point. This is connected. Suppose its resistance is here. Suppose its resistance is here. Then this is one node, this is another node. There is no resistance here. Simply line is there. Simply line is there. There is no resistance in between these two, in between these two, in between these two. This is connected here. This is also connected here. This is also connected here. So we are having only one node, that is V1. We are having only one node. Okay. There is no resistance in between the lines. All are connected to single point. Is it clear?
Yes, sir.
Okay. Otherwise, if you are getting confused, you can modify that. Now here, to this node, 4 branches are connected. 1, 2, 3, 4. So I am saying, first, what is the first solution in nodal analysis for determining node voltage? For determining node voltage,
Consider current direction.
we have to assume all the currents are leaving from the node point. We have to assume, since 4 branches are connected, I am taking 4 currents here. All the currents are leaving from the node point. My assumption, I am forgetting about the actual direction of current they have given in the problem, I1, I2, I3. I won't consider those things for determining node voltage. For determining node voltage, I am assuming all the currents are leaving from the node point. Let us say this is I1, I2, I3, I4. Our assumption current direction. Totally you get 4 currents here. That is, this is I1, let us assume. Don't mention anything. I1 plus I2 plus I3 plus I4. Because all are leaving. If the current is leaving, we will take plus. Now, what is the first current? What is the first current? This is the branch. What is the current?
V1 plus 6A.
No.
Minus
Directly
6.
the current here. This arrow is upward, incoming. Since
Sir,
I am comparing the node,
Minus 6.
we are taking it as minus.
V1 minus 6.
V1, no. That
minus
is
6
directly
to 1.
current. This is directly current. If you want current, D by R. But here we are not having any voltage. We are not having any resistance in this branch. Directly current is here. What is this current? 6 ampere. They are directly giving 6 ampere. There is no voltage and there is no resistance here. Directly current they are giving. If current is entering into the node point, we'll take it as minus. If the current is entering into the node point, we'll take it as minus. Now come here, second branch, plus, okay, plus, what is the current? I is equal to V by R. V1 minus 0 by 2. This is V1, your arrow is like this, from this node to this node. V1 minus 0. V1 is at higher potential, 0 is at lower potential. V1 minus 0 by 2. So this is V1 minus 0 by 2. Voltage divided by resistance is current. But in the first case, they are directly giving the current. If current is entering into the node, arrow is like this. But this arrow and this arrow is opposite direction. That's why minus. If arrow is in the downward direction, we'll take plus. This is voltage by resistance is current. This is directly current they have given. There is no need to write voltage by resistance. There is no voltage. Directly current is given in this. Current is flowing. This current and this current are opposite direction. That's why I am taking minus. And V1 minus 0 by 2. Now what is the current in this one?
V1 minus 8
V1 plus 8.
V1 minus 8 minus
minus
0
0 by 4.
4. Voltage is in the numerator, in denominator resistance. Here fourth one, next last one. Okay. Totally 4. 1, 2, 3, 4. 1, 2, 3, 4. Totally 4 components you will get. 4 currents. All the currents are leaving That's why I'm taking plus here. First one, second one, third one, fourth one. Now simplify this, you will get V1. V1 into 1 by 2 plus 1 by 4 plus 1 by 3. That is equal to 6 comes to this side plus 6. 8 by 4 minus 8 by 4 is minus 2. If it comes to that side, it is plus 2. 8 by 4 is 2. Minus 2. Minus 2 comes to that side plus 2. From this, you will get V1. Okay. In this way, we will determine node voltage. So in the previous problems, we have not taken current source. But in this problem, we have taken the current source in nodal analysis. This is directly current, the current generated. Next, I am determining current in this branch. Voltage divided by resistance is current. Similarly, voltage divided by resistance is current. Voltage divided by resistance is current. This is directly current source. Calculate V1.
96 by 13, sir.
96 by 13.
7.38, sir.
That is your voltage. Now come to the actual current. Now we'll determine the actual currents. I1 is equal to, what is I1? I1 is flowing from 0 to V1. 0 is a higher potential, V1 is a lower potential. 0 minus V1 by
2. 0 minus V1 by 2.
next, what is I2? What is I2?
V1 minus
0 minus
V1 minus 0.
See the arrow.
0.
0 plus
I2.
0
It is flowing from V1 to 0. If it is flowing from V1 to 0, what is that, right?
V1
V1
minus 8
V1 minus
plus
8.
minus 0.
Why minus 8?
It's
It is
from
flowing
plus
positive
to
to
minus,
negative.
sir. Positive to negative, sir.
Minus 0 by
0 by 4.
4. Next, what is I3? I3 is flowing in this upward direction. What is
0,
it?
0
0
minus
minus,
2
V1
minus
minus
V1 by
V1
3.
by 3.
1 by 3.
we know V1. We have calculated. Substitute this, you will get I1, I2 and I3. Go through the problem. Okay. In this way, we will determine the node voltage and branch current. I'll give one problem as homework to you so that you can solve and you can post it in the WhatsApp group or you can write in your notes. Determine node voltage and branch currents using nodal analysis. So you try to solve. Meanwhile, I will take the attendance. How many nodes are there?
One, sir.
Only one
Yes,
node
sir,
is
one.
there. Okay.
Yes, sir. Only one.
Only one node is there.
So
Ah,
So, but we have
how to
resistance, no, sir.
reduce this circuit and solve?
what I'm not getting?
But there is a resistance, no, sir. You may get 2 nodes.
No, no. If suppose if the resistance is here, if resistance is here, we'll get two nodes. See, this is one branch. This is one branch. This is the last branch. Always voltage is in series with the resistance. This is one branch. We can connect this 4 ohms here. What is the problem? I can connect this 4 ohms here. This is only one branch. Suppose if resistance is here or here. Suppose if resistance is here, this is one node. This is the second node. This is the third node. We'll get 3 nodes now. We'll get 3 nodes here. This is V1, this is V2, this is V3. But there is no resistance here. Here also there is no resistance. All are connected
And
to
nodes
line.
are counted between the resistor, sir.
What? Tell me.
Nodes are counted between the resistor.
Not between resistors. See here. If resistance is here, we can't take like this and we can connect like this because resistance is in between. If resistance is in between, here one node point is created. Here also one node. Here how many branches are connected to this? 1, 2, 3. Suppose if resistance is not here. If resistance is not here, this branch is connected here. This branch is also connected here. So in nodes will be created extra. If resistance is here, nodes are created here. If resistance is not there here and here, there is only single node. Short circuit path is here. There is short circuit path. If resistance is here, this is not short circuited. Node will be created here. If resistance is here, nodes will be created. In between these two branches, resistance is here. In between any two parallel branches, if one resistance is in between, node will be created. If in between two branches, if there is no resistance, this is short circuit. In short circuit, nothing is there here. Then it will be considered as only one node. These 2 points are connected to the same point. Suppose if resistance is here, then this is one node, this is another node. Now 1, 2, 3. 3 branches are connected to this node. To this node, 1, 2, 3 branches are connected. There is no short circuit here. Suppose if resistance is not there, there will be short circuit. If short circuit means nothing is there in between. So we can take this as one single point. This is connected here, this is connected here, this is connected here. Why I have not, this resistance is not counted means this is one branch. 5 ohms, 4 ohms and 5 ohms are in series. This is considered as one branch. The entire branch is connected to this point. The entire branch is connected to this node. And the last branch, if there is resistance here, that will be taken as one branch only. Suppose if the 4 ohms is here, between these two, then here one node is created here also one node is created. Okay. If short circuit is there in between the branches, then we will get only single node. See, short circuit is there. Then nothing is there. From here to here, nothing is there in between the lines. Then it will be treated as single node. Suppose resistance is coming here one node is there, here also another node is there. 2 nodes is there. This node is connected to 1, 2, 3 branches. This node is connected to 1, 2, 3, 4 branches. Right. Now I am taking it as single node. This is connected here. How many branches are there? How many branches are connected to that node?
5.
5 branches. Okay. Let us take the actual current also. Let us take this is I1, this is I2, this is I3, this will be I4. Anyway, this is the current. Okay. Now, I want to determine node voltage. For determining node voltage, what is the assumption?
Current flowing out of node 1.
Yes, sir.
All the currents are leaving from the node point. This is 1, 2, 3, 4, 5. Totally 5 terms in there. What is the first one? Plus 6 or minus 6?
V1 minus 6.
Because we are
Sorry,
considering this
6.
direction.
Only 6.
But actually
Minus
it is
6.
the opposite direction. Minus 6. If this direction and this direction are opposite, we'll take minus. Suppose the arrow is in the downward direction. This current is leaving from the node point. We'll take plus 6. Now here V1 minus V1 minus 0 by
3.
Next, what is the next one?
Minus 8.
Plus 8.
Plus
Plus 8. See, this arrow and this arrow, both are in the same direction. This arrow and arrow is down. This current is also leaving from the node point. If it is leaving, we'll take plus 8. Next, what is the next one?
V1 minus 0 by 2.
V1 minus 0 by 2. Plus,
V1
what is
minus
this?
4
V1 minus 5
by 4.
0 by
4.
Okay. Now simplify this, we'll get V1. Next, you can do it at home. Next, what is I1? I1 is flowing in the upward direction. 0 minus
V1 by 3.
What is I2? I2 is on 8 ampere only. Don't take this side. I2 is 8 ampere.
8, sir.
What is I3?
V
0 minus V1 by 2, sir.
0 minus V1 by 2. I4?
V1 minus
V1 minus 5 minus 0 by
5 minus 0.
Take them the problem. Meanwhile, I'll take that and then.
Sir,
can we get negative V1?
negative voltage.
Negative, we'll get the negative value also.
Okay.
Okay.
Because the currents will be 6 ampere is one and 8 ampere is one. It may come negatives also, you can get no problem. That is not an issue. Okay. Depending upon our value of the resistances, depending upon the voltage and current sources in the problem, that node voltage may be positive or negative. Okay.